I hope everyone's having a great morning. I am Mr. Ish. Thank you for joining me. Here we're looking at a Maclaurin series application which will involve binomial expansion. How can you utilize all of that? Series expansion and binomial expansion to solve something like this, square root of 1.02. I will show you. When you're thinking about the Maclaurin series, you know you have a representation such as this. It looks something like that. But you have to bring everything into this type of form. And how can you do that? You can do that by means of a binomial. But what's a binomial you see over here? 1 plus 0.02 all to the power of 1 over 2. Here's my binomial. It looks like something like 1 plus x to the power of n in this type of form, but it is a binomial. Now what we have to do is work with this. And how can we work with this? Well, I'll show you. When we are looking at something like this, I have something which looks like 1 plus x to the power of n. That's what I have. And it can represent a zero order derivative. You know when you're going to put in the Maclaurin series, which is centered around 0, when you put 0 here in places of x, you'll have 1 to the power of n, and you'll just have here 1. The first order derivative obviously is going to be easy. You're going to do n times 1 plus x to the power of n minus 1. You're bringing in the power rule over here, the basic derivative power rule. Very easy. Center this around 0, you're going to put 0 in places of x. What will you have over here? You'll have an n. Your second order derivative is going to be what? You do the derivative of this power rule, n times n minus 1 times 1 plus x to the power of n minus 2. Remember, the exponent is reduced by 1, but the exponent becomes the coefficient of your function. And when you put 0 in places of x, you're getting n times n minus 1. And then you know the third order derivative is not hard. Just run it again to the power rule, and it's going to be easy. When you put in 0 over here, you're getting here n times n minus 1 times n minus 2, because this part right here always goes away. It's always 1 to the power of some number, which is always equal to a 1. And you know the fourth order derivative, I won't even write this part out, but you can imagine it will be n times n minus 1 times n minus 2 times n minus 3. That's what it will be. But what have we determined over here? We've determined here this part. Now we have to look at this part. And that's easy. It's not hard. When you're looking right over here, what are you seeing here? This is in the 1 plus x to the power of n format. N here is equal to 1 over 2. X here is equal to 0.02. We're not ready yet, but we're almost there. Well, let's look at this part and let's combine it with this. When we do our series expansion will be something like this. 1 x minus 0 to the power of n divided by 0 factorial. All of that is just going to be a 1. So our first term will be a 1, but our next term, you'll have this, and we'll start bringing in these items. We'll have n times x to the power of, this is my 0th term, this is my first term, over 1 factorial plus. Let's come right over here. N times n minus 1. Remember, this is the binomial expansion coming into the Maclaurin series expansion, which will help me calculate all of this. And here we'll have x to the power of 2 over 2 factorial plus. Then we'll come down over here. We'll have n times n minus 1 times n minus 2 times x cubed over 3 factorial plus. Let's bring in the last term right over here. It'll be n times n minus 1 times n minus 2 times n minus 3 times x to the power of 4 divided by 4 factorial plus, and on it would go. Now let's make some space. Consider the template I have over here for you right here. All of this my template, and consider these substitutions which will come in. My first term is a 1. By this item we'll be having here a 1 over 2 times x, which is here 0.02 to the power of 1, which is just 1. 1 factorial is just 1. Remember, here you would have had times x to the power of 0 over 0 factorial, which is just a 1. It would have retained this 1, so I did not even bother bringing it in. Anyhow, now let's do this item right here. We'll have here a 1 over 2 times 1 over 2 minus 1, which is a minus 1 over 2 times 0.02 squared divided by 2. Will come right over here plus, in places of n, 1 over 2 times minus 1 over 2 times minus 3 over 2 times 0.02 cube over 3 factorial, which is 6, plus last items coming in right here. It will be a 1 over 2 times minus 1 over 2 times minus 3 over 2 times minus 5 over 2 multiplying by 0.02 to the power of 4 divided by 4 factorial, 24. Now look, these are my terms. I have one term over here, I have one term over here, one right here, and one right over here. And I have obviously this. What I'm going to do is I'm going to eliminate all of this, and I'll just base my answer Only on these first four terms, you could have added this fifth term right here. It's fine, but I'm removing it. If you add it in, you'll just have a more accurate of an answer, but I'm just removing it for the purposes of this video. We'll just make our computation based on this. I have here a 1 plus 0.02 times 0.5, a 0.01. Here I'll have a minus value. It'll be 0.02 square times 0.5 minus times 0.5 positive divided by 2. These are my values coming in here. It's minus 5 times 10 to the minus 5, which you can write as minus 0.00005. And this item here will be positive. The two minuses will cancel out. Here, if you compute this, what will you have? You'll have 0.02 exponent 3 times 1.5, which is a minus value, times 0.5, which is a minus value, times positive 0.5 divided by 6. These were my items: 0.02 cube, minus 1.5, minus half, and positive half divided by 6. I'm having 5 times 10 to the minus 7. Let's make sure we have the right number of decimal places. 1, 2, 3, 4, 5, 6, 7. And let's compute this. The computation of this will give us the value of this. Not the exact value, because we have not gone up to infinity, but it'll give us a close enough value. I'm going to sum all of these up and I'll put the value for you right here. I'm getting a 1 plus 0.01 minus 0.0005 plus all of these zeros and then a 5. I have 1.0099505. Let's put it down. That's what I have, 1.0099505. Now what I will do is take the 1.02, my original question, I'll square root it, and then we'll compare our answers. I have 1.00995049 coming here, but here what we have is very close to it. This is my only difference here from the calculator. The calculator from this point on is giving me a 494. But remember, this last term which I omitted, it would have been a minus term. This minus term would have brought this value which I have down into this range that you see. Anyhow, it's a very good exercise over here. You can see Maclaurin series adapting a binomial series expansion to help you solve something like this. That was the purpose of this video. Have a good day and thank you for watching.